Hello. Today I will be discussing 12-factor app. 12-factor app is a methodology for building mm, modern web apps. So in today world, like web apps, we are building as a services which are being deployed on the cloud. And it's very important that when we are deploying our services, we should be able to move our applications from one operating system to another operating system, and they should be able to scale because on the cloud the uh, lot of people can watch your use your applications, so the usage of your applications can be very high. So it's very important that you follow a good methodology to build applications that are scalable. So so these 12 factor app are is a methodology where they have come up 12 rules. So these are the summary of the rules. We'll go each row, each factor one by one. So it's a open discussion. You don't have to wait for last. Like we discuss factor one, we can discuss in the end. Free feel to give your input. Keep You guys can keep your mics on. So feel free to give your input. What you guys think, is it useful in today's world? Are you using it? How we can implement it better? The first thing is code base. It says that your application should have a code base. There should be one-to-one relationship between your app and code base. So I have seen somewhere like people went to work on a job and they found out there was no code for the application. So first thing is you need to have a code base. Second thing is second thing is like it says like if your application is using 3 repositories, it's a that is a violation of this rule. So you need to have 3 applications and 3 repositories. Another thing it says, if your application is using some shared repository, that is also a violation. So you need, if you need some common code, that should be deployed as libraries, and that should be deployed as NuGet package as part of dependencies. So you may have a shared code base and you developers may have different commit. You may have different commit in staging. You may have different commits in the production. So what you guys thinks about this one? That means this one is with GitHub, like pretty much it is microservices architecture. That's what we are following. You need to have whole code in your repository. All the related code should be there. So any thought, any comments? Okay. Second thing is interesting that it says you need to explicitly declare and isolate dependencies. So in older words, what we used to happen is like what it means is don't use system-wide dependencies. If you remember like older word, we used to deploy .NET 4.81 traditional .NET framework on server. So like a lot of time we were deploying our application on a server which was being used by other teams. We had a shared server. So you have to deploy .NET on the machine. And I remember once I was working on some latest framework, and I was going to deploy on the server, like one architect who was good friend of mine, he told, "Are you crazy? Are you going to take the first hit of deploying the latest .NET version on production server? What if other apps goes down?" So that is the problem if all the apps are using the same system system dependency. So you may install a new versions, older applications may working, stop working. So you were taking a chance. So in .NET Core, or in especially in Docker world, what you do is you deploy app and you deploy your dependencies. You're deploying .NET 8.0 version within your app one. App two, you are deploying your .NET 8.0 version. So this way, each app can has its own dependencies. They are not uh, relying on the server. The one advantage is like if this virtual machine, if this server goes down, I can just lift and shift these apps to another server. I don't have to worry about system-wide dependencies. So that is the benefit of using this factor two law, that never use system-wide dependencies. Another thing is about this one is in .NET framework, you can have a package file, and in this package file, you can declare all your dependencies. So, guys, any comment before I move to factor three? So, don't use system-wide dependencies. Declare your dependencies. This is pretty clear.
Okay, one question.
Sure, Aditya.
Uh, okay, I thought 12 factor is some kind of technology. So it's a way that we can um, our maintain application by 12 way, correct?
That's correct. These are like principles.
Uh-huh.
These are principles. These are more a methodology, like how you design your new system so that it scales on cloud environment.
Okay, thank you.
So I think you can relate a lot of stuff, right? How we used to
Yes, yes.
do traditionally, and what kind of problems we used to face, like when we were deploying .NET assemblies in GAC. You remember that DLL
Yes.
hell?
Mhm.
So
Like,
so in .NET Core, that's the advantage that uh, we can deploy, especially Docker has made it very, very easy, the container technology. In the Docker, you deploy your app with dependencies. It's lightweight. You don't have to deploy the operating system between your container. And a lot of these principles you see when you are using Docker, you're taking care of so many things here.
yeah, okay.
So third thing is it says store configuration in the environment. So Aditya, Karan, you must have remembered we used to store configuration in our web.config, and you would have database connections, all the
Yeah.
secrets inside the configuration. And then you had contractors, and contractors were not supposed to know your production information, but you have a configuration file where you have connection string to the production. You have, if you have some other like message queue, or you have some authorization, some keys which are very secret, all the information is in that configuration file. Everybody's know. So in Azure, it's very convenient. Like you can have Azure Vault. So the benefit of having configuration in the environment is most of the time, what is different between production, staging, and development? Most of the time, it's connection string. You are connecting to some third-party services, their addresses, and so when you store these values in the environment, you can always move these copies files from production to from development to staging to production. Remember, like there was time we moved our test configuration file to production, and we messed up our production environment. Then we have to go get backup configuration file. So this principle says that we need to store configuration in the environment. So that way, like if we decided to make, nothing secret should be there in our source code. So tomorrow we decided, okay, our GitHub will be available to public. So no secrets of the company should be revealed. Nothing wrong should happen. So any question, any comment on this factor three?
No.
That this pretty straightforward, right? Makes sense. So factor four is backing services. What it says like you need to track your backing services as attached resources. One minute. So lot of our application we are connected to SQL Server. We are using some email service. We are using some Twitter feed. We are connected to Amazon Web Services. So what it says is like they should be treated as attached resources. So suppose from SQL Server, I'm converting to Oracle. So it should application code should not change. So if we are using ORM and this ORM maybe in C Sharp entry framework, if it supports Oracle, so there should not be much coding changes. If we are using some email services, we should make sure that we are coding against interfaces. Again, Amazon, again, we should make sure that we are using some interface. And tomorrow we change Twitter to something else. As long they are supporting our interfaces, we should be fine. We should be fine. So, do you agree, guys? Like this is a good design that uh, this databases, email server, Twitter feed, all third-party resources should be lightly coupled to our system.
Yes.
So factor five, I think we are all implementing kind of like it says uh, the build, release, and run should be a separate processes. They should be separate activities. You should never modify the code once it has been released into production. I have seen people where people modified some ASP.NET files, text files, and they deployed on the production and never checked in the repository. So any GitHub repository. So this you should never make changes, but once it has been deployed into a environment, so this is the principle which makes sense. Like build, you are just building your code into EXEs. Release, you are pushing them to proper server, and they are running in servers. And once this process is done, uh, you should never make changes in the production. So have you guys seen some time like there were changes and never checked in repository? So this one is straightforward. It says execute the app as one or more stateless processes. So when like a website, when we are building website, what we do? Like, we in traditional website we used to use user sessions. So what happens is when you are using user sessions, then what happen like one you tie user to one server. And when you are using user sessions, chances are you're use sticky sessions. When you are using sticky sessions, and if your session time is 60 minutes, so let's say one server can handle 60 users. So once 60 users are gone, that server is gone. That server cannot take any more requests. So that's like you should not store the state inside the web server. You should not make them sticky session. So that way you can handle lot more people. You can take load. You can scale your application to a bigger user load. Any question before we move forward I think this is very old principle. This is considered means this has been as long as the distributed programming has been, this principle has been that it's always good practice to use stateless processes. It- this is one is interesting that export services by port binding. What does it mean? So in traditional environment, like we used to deploy our application in ISS server. So all the requests were going to ISS server. ISS server will take this request and move to your web applications. So, but this is not a good practice on cloud. Cloud, your application should have everything. As we said, dependencies should side inside application. So when you deploy your application in Docker, it has everything inside it so that it is directly listening to the server. So this way, like when you move your Docker application from one server to another server, you are just lifting and shifting this container. Uh, you don't have to see what ISS version was it running, but was it ISS 5.0 or 6.0. So you just move it. So I think this even .NET Core framework gives you some options where you can deploy your web server in the app and it can listen to the port. So that way, like if you are installing your container on Amazon, they don't have to worry about ISS, Windows operating system, all those details. Then this way, it is tightly coupled to the server. You can change from Windows servers to Linux servers without worrying about the external dependencies. So does it make sense? Any comments, any questions?
Yes, regarding this port, we faced so many issues on hosting IIS. So this is a good solution
Very
to
good
add on.
solution. ISS was very heavy, right? ISS as
Uh,
compared to Docker. So scale out by the process model. So this can be thought about two way. So one is traditional one. In traditional one, so instead having just web application, a lot of time all of us has written Windows services, right? So there was some backend process. We just write the Windows services and we can deploy on multiple app servers and it can take some processing. That is one way. Another one way, another way is event driven design. So some events happen and you have some background processes which are listening to those events or messages and they are doing some processing. So this way you take a lot of processing away from your web application and you can scale it. So this is in the traditional way. So in microservices world, how you do it? In microservices, you build small applications. So you have some applications. You guys have some a e-commerce website. So in e-commerce website, you have a catalog. So and there's a checkout. So chances are a lot of people are going to come to catalog, check things out, see things. So maybe in the catalog microservices, you may be getting 1 million views. Whereas the checkout, very few people are going to check out. So you have 8 servers for catalog microservices. Whereas checkout, since the volume is very less, you may have one server. So this is how you scale out by the processes in microservices world. So any question on here?
no.
So disposability, maximize robustness with fast startup and graceful shutdown. So in the cloud environment, like if you write some bad code, like you have written some very bad background process, and which is reading files, log files, and processing it, but it's not disposing those objects. It's not cleaning up. So there's a memory leak. So lot of lot of time you will be sharing your resources with other tenants. So these cloud providers, they're going to shut down your service immediately when it crosses some thresholds. If it has it has gone ahead of its own share of memory, CPU processing, they're going to shut it down. So when it's shutting down, this is your responsibility that you have to make sure it shuts down gracefully. Means that you are processing some order, and those orders should be in proper state. They should not be inconsistent state, and they should be able to start immediately. If the startup time is too much, that is not good for from the user experience point of view. So this one, like when you're deploying on the cloud, you should be ready. They're gonna shut it down when it reaches thresholds. So when you're deploying some background processes on your server, you have lot of leeway, lot of control. You can ask admin to increase the memory as long servers. I have seen as long server doesn't come down, uh, nobody cares. So once the server is down, people gonna come after you. So this is another thing you need to take care in microservices that's being deployed on cloud. So dev production parity. Oh, so how many guys you have worked on environment where your dev environment was different, staging environment was different, QA environment was different. You had different version of .NET in development. You had a different version of .NET in production and test. Have you guys seen those kind of scenarios?
Yes, sir, we faced this.
So that it says that this is a good one. Like you need to keep your development, staging, and production as similar as possible. Because a lot of time, okay, we could there were issues in the production we couldn't figure out in the test because the environment were same, things were working in the test QA, and once we moved to production, they stopped working. Because and again it was, if you could, you cannot recreate those kind of scenarios in development machine or productions on or QA's environment, how difficult it is to create. So this is very another good law that you need to keep development, staging, and production as similar as possible. um, they should not be too different from each other. So factor 11, it says treat logs as streams. So traditionally, what we used to do, we used to write in a big file. It keeps growing till it blows up the server, or nobody cares about reading. So what it says that logs should be treated by the environment. What it means is now there are a lot of framework where they are when you stream your log, there are tools which are consuming these logs and sending to some another databases so that it can be analyzed later. So there are tools like Elasticsearch, which handles this task for you, like in Azure, uh, Application Insight uh, can go read the logs and give us some useful insight. So that's what, like we need to treat logs as the streams. And .NET Framework, gives you options. You can write your logs to Application Insight or different databases or different environment. You don't have to just push into a big log file. So the factor 12 is, it says run admin management tasks as one of processes. But it means a lot of the time we have utilities. We need to move some data from some system to our system. We have some utilities where we create test accounts. So what it says is all this code should be in the repository, and you need to deploy 11 all these factors, 12 factors methodology to even these management tasks. A lot of time we think, okay, we're gonna use it and throw it. Why to worry about these capabilities? We will, once it's done, we'll throw it away. We will not check in this code into will not check in this code. And uh, so a lot of time then you need this. Sometimes you want to create some users, you want to rerun the data, you wish this code was there. But you don't have to reinvent the wheel. So guys, that concludes our factor 12. So what are your thoughts, like uh, what do you guys think about factor 12? Like uh, do they will help us to write good code, write applications, modern applications that can scale on cloud environment? Yes, Aditya. Yes.
Yes,
So,
yes.
Vikas, this is one-off process. Like, can it be regulated? Like, we can have it as a scheduled process also. That so that like, or is it just admin, like one-off management task and one just and then forget about it after that? Is that what?
That's what it's saying. It reads like that, but it means it is saying don't treat it. Whatever those utilities are there, make sure that they are in the repository, and you're following all the all the good practices as we discussed. Don't do a bad job, like okay, I'm moving code from this server to another server, and I will not need this one, so I'll throw it away. Don't do it like that. So the scheduled job, you will make sure that it's in the repository. They are following good practices. It makes sense.
Yeah, yeah, that's good. Yeah.
So what do you think, Karan, about these 12 factors?
I think they are. Yeah, it's a better. Yeah, I understand it better. Like one this and that. Yeah, I understand it now. It's good way. One this factor 1, 2, 3, 4. From early on, it was good, and then later on, it is more of a so one it more granular, I would say, and then I did not, but it's a good way. I think I liked it. It's good.
Awesome.
Yeah.
So Aditya, what do you think about these uh, factors?
It's some of these factors, and we directly or indirectly we follow this, and some
Okay,
of not. Some, but these are all these good factor to implement in our application. It's
cool.
really good factor.
Okay. Kilani, any thoughts?
No, I'm still it's I mean, I really like that microservices stuff. I really like that the catalogs, like where you have multiple servers by
Mm-hmm.
splitting them into multiple microservices. I mean, that's really going to be very useful. I mean, for the businesses, right?
Cool. Okay, guys.
Mhm.
Thank you. Good night. Take care. Bye bye.
Bye.
Thank you, guys. Thank you. Yeah. Bye.